right, this is homework number 7. First set of problems, we're just doing 1A. It says, estimate the slope of the graph at the points x1, y1, x2, y2. So we are estimating this slope right here. I think I can get points off of those. I don't really know why they need me to estimate it. I guess I could say, well, it's somewhere between 0 and negative, whatever I think this is, -2 or something, but I'm just going to calculate it. It looks like x1, y1 is at -3, 3. And it looks to me like x2, y2 is, it's not quite at 2, 0, but I'm estimating, so I'm going to make it at 2, 0, and this will be my estimate. Not sure why my pen is being so spotty. So yeah, I'm going to say, all right, slope is about change in y over change in x, -3/5. That's my estimate for that slope. Gosh, did I do it the same way in the key I posted? Let's find out. Yeah, okay. All right, just making sure. All right, we're only doing number 3 in the next set. So use the graph shown in the figure. Number 4, insert the proper inequality symbol, less than or greater than, between the given quantities. So we are comparing the average rate of change from 4 to 1 to the average rate of change from 4 to 3. So I'm going to sketch these in. So here's 4, average rate of change from 4 to 1 versus the average rate of change from 4 to 3. Definitely 4 to 3. They're both positive. 4 to 3 is less, or 3 to 4, I should say, is less steep. So it's a lower positive number. So I'm going to say that this first 4 to 1 is a greater than. And then part B is asking you to compare that slope. Let me erase the extra one off. The slope from x equals 1 to x equals 4 to the tangent slope at 1. So sketch that in. I guess, you know what? It's already kind of sketched in. Oh, maybe that was just pencil in my book. Anyway, they're both positive. F prime looks much steeper. So f prime is greater than in this case. So the secant slope is less than the tangent slope in that case. All right, number 5. Find the slope of the tangent line to the graph of the function at the given point. So find the slope of the line tangent. Now, we have a linear function right here. So if I'm finding the slope of the tangent line, the slope of the tangent line is just this slope. There is no like variation. So this is a slope with a line this is a line with a slope of -5, so I don't really have any calculation to do. This is a linear function. If this were nonlinear, I would need to find f prime of -1 and go through that whole process, but I don't need to do that for this. All right, number 13 and 18, it says find the derivative by the limit process. So find the derivative means you need an equation for f prime of x. And you can't use that alternate definition because that's to evaluate the derivative at a certain c value. This is just find the derivative. So now, again, f of x is linear, so I'm actually not going to do the work for this. We did this back in pre-calc. I don't need to do the limit as h approaches 0 of the difference quotient because f of x is linear, so f prime x will always be the slope, which is -10. Remember, the derivative is just what is the tangent slope. And if you have a linear function, the tangent slope is the slope of the entire line. Now, number 18 is quadratic, so I do need to do the limit process here. So f prime of x is equal to the limit as h approaches 0 of our difference quotient, which is, let me just put it in my generic formula first, f of x plus h minus f of x all over h. So let's plug stuff into that. So remember not to drop your limit notation until the very last step. So find f of x plus h. That's 2 minus the quantity, x plus h squared, minus the quantity, 2 minus x squared. All of this is over h. All right, and the next step would be limits as h approaches 0 of 2 minus, this is going to be x squared. It'll be minus 2xh minus h squared. I've squared this and I've distributed the negative through. Minus 2 plus x squared. Remember, as we are simplifying the difference quotient, anything that does not have an h in it should cancel out along the way. So 2 minus 2 is 0. Negative x squared plus x squared is 0. And remember to divide every remaining term by h. So this is negative 2x minus h. That's, oh, gosh. With limit notation still. Sorry. I was switched to pre-calc mode where we were just finding the difference quotient. So, excuse me. So limit as h approaches 0 of 2x, negative 2x minus h when I divide by h. And then finally we plug in 0 for h and we get negative 2x. F prime of x is equal to negative 2x. That means we can calculate the tangent slope at any x value by just plugging into negative 2x. All right, number 25, part A and B. Find an equation of the tangent line to the graph of f at the given point. So because we're finding the equation of the tangent line, we need a point, which we have. The point is 1, 4. We need a slope at that point, so we need to find f prime of 1. And we can do that, remember, with our alternate form of a limit definition of a derivative. So this time it's the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. So again, keep the limit notation until you are ready to evaluate. So f of x is x squared plus 3 minus f of 1 is 4. You don't need to plug that in. It's given to you right there. X minus 1. Now this is x squared minus 1 in the top. Okay, so now it's the limit as x approaches 1 of x plus 1. So that's 2. 1 plus 1 is 2. So f prime of 1 is 2. And now I have a point and a slope, and I can write a linear equation for that. So y minus 4 is equal to 2 times x minus 1. That's my tangent slope equation. You can leave it in point slope form. Use a graphing utility to graph the function and the tangent line. I used a graphing calculator here, but remember we're using Desmos this year. So I just want to just kind of verify in here. So I can type in f of x equals x squared plus 3. And then the nice thing about Desmos is you don't have to solve it for y like you do in your graphing calculator. Not that this one is all that difficult to do. You can type in an equation in point slope form and it will graph it. Okay, so this is a good sign. Actually, let me just update my answer key while I'm doing this. So there's that. All right, and then it did say to find the derivative feature. I do want to show you how to do that in your graphing calculator because it's kind of nice. Sorry. Okay, so it is kind of nice to be able to know how to evaluate derivatives on your graphing calculator. We will do this formally in a couple of days, but why not just show this? So I have f of x typed in here. I can type in f prime of, 1? And see how it gives me that value? It gives me the value 2, which is the slope that I found. So kind of nice. We can confirm the answer that we got here for f prime of 1. All right, number 51, sketch the graph of a function whose derivative is always negative. Explain how you found your answer. So we need a graph where f prime of x is always less than 0. And what that means about the function is that f of x is decreasing for all real numbers. So you can draw any function that's decreasing, and I would say just make sure it doesn't have sharp turns or discontinuities. So I'm just going to draw here's a linear function that is decreasing. That's my f of x. So that definitely has a negative derivative for all x values. All right, number 60. Assume that f prime of c equals 3. Find f prime of negative c if for part A, f is an odd function, and B, f is an even function. And it says, oh, I don't need these directions, do I? Cutting that. Okay, so anyway, so for number 60, find f prime of negative c. So for an odd function, if a function is odd, it means that f of negative x is equal to f of x. And if you have an odd function, it's like some sort of origin symmetry. So let's just say we have something going on like this. So f prime of c is 3. Let's just say that could be here. That could be a slope of 3. So then f prime of negative c, is that going to be negative 3 or not? Let's take a look. So let's just say that points at 2 or whatever. Here it is at negative 2. Is that slope? It's definitely not negative 3. It looks to be like they could be the same. I understand this is a very rough sketch, but it seems to me like f prime of negative c would also be positive 3. And then what if we have an even function? Let's kind of sketch an even function. I always go for the classic parabola. I have an even function because even means f of negative x equals negative f of x. But remember that the rule doesn't have to be true with derivatives. We don't know that that means, oh gosh, I didn't write that correctly. Sorry. We don't know for sure that that's like, oh yeah, and because we haven't learned about derivative rules yet, we don't know that because this relationship, sorry, I'm writing it wrong. We don't know that just because this relationship with the functions is true, it doesn't mean that I can just throw primes on there. It's actually not true. So they are the same value here. So it means that f prime of negative c was actually equal to the same as f prime of c. Let's take a look at the even function. So I'm going to say c is here and say, yeah, it looks like a 3 slope, sure. So negative c is symmetric across the y-axis. That definitely looks like the negative version of that slope. So I would say in this case, f prime of negative c is probably negative 3. In a few lessons, we will learn about something called the chain rule, where we can prove that these have to be opposites and these have to be the same versus even and odd, but we will get into that later. Right now, we're just doing things visually. Number 64, the figure shows the graph of g prime. So this is a derivative graph. I'm just going to write that down to remind myself that. So g prime. So what is g prime of 0? So this is the graph of g prime. So g prime of 0 looks like it's negative 3. G prime of 3, mark that off here, looks to be about 0. What can you conclude about the graph of g? So not the graph we're looking at, the graph of g, knowing that g prime of 1 is equal to negative 8/3. So it's not the 8/3 that matters, it's the fact that it's negative. So I can say since g prime of 1 is less than 0, g of x is decreasing at x equals 1. That's really all we can say about that right now. And what can we conclude about the graph of g knowing that g prime of negative 4 is equal to 7/3? It's not the 7/3 that matters, it's that it's positive. So again, since g prime of negative 4 is greater than 0, g of x is increasing at x equals negative 4. It's important to write where that's happening because g of x might not have the same behavior at every single x value. It probably doesn't. So we're just talking about what we know at this specific location. This doesn't tell me about what's happening anywhere else on g of x. Is g of 6 minus g of 4 positive or negative? Explain. So let's see. G of 6 minus g of 4. It would be positive if g of 6 is greater than g of 4. Right? And it would be negative if g of 6 is a smaller value. And all we have to go off of are the derivatives. So let's take a look at the derivatives at 6 and 4. So g prime of 6 is equal to something pretty positive, right? It's definitely greater than 0. G prime of 4 is also positive, but not as high. It's also greater than 0, but g prime of 6 is greater than g prime of 4. So what does that mean? It means at 4, you've got g of 4 sitting somewhere. Let's just say this is g of 4. And then because the derivative is positive from 4 and beyond, the g of x graph is increasing some sort of way. Might be curved, whatever. And so g of 6 is definitely sitting above g of 4. So when you subtract them, you know that their difference will be positive. So g of 6 is greater than g of 4 because g of x is increasing on this interval 4 to 6. So g of 6 minus g of 4 will be greater than 0. Is it possible to find g of 2 from the graph? Explain. The only reason this is no is because we need one point that we know for sure. We need one position for the g of x function to be able to use calculus to figure out what g of 2 is. We also don't have the calculus skills to figure that out right now. So no, the reason is because we need one known point on g of x. Point on g of x to find other values. I'll say based on how would I do it, say I had g of 0, I would find the area between the x-axis and my graph until I got to 2. And whatever that area is the change in position. So no, because we need a known point on g of x to find other values based on the area under the g prime of x curve. More on that later when we get into antiderivatives. Okay, these are our last two. So use the alternate form of the derivative to find the derivative at c. So definitely my favorite form to use if I'm just evaluating. What they're asking you to do is find f prime of c, so in this case, f prime of 3. And we need to use the limit process, but the limit as x approaches 3 instead of h approaching 0. So the limit as x approaches 3 of f of x minus f of 3 over x minus 3. I like to set it up like this first for two reasons. It makes me practice this limit definition, which we don't use all year, so I do even myself. I need practice with it. But also, it just helps me from making a mistake or leaving something off. So now I'm going to put in what f of x is. It's x squared minus 5 minus f of 3. What do you get when you plug 3 into this? Do that off to the side. 9 minus 5 is 4 over x minus 3. Okay, I'm going to do a bit of math off to the side here. I do get sick of rewriting this a million times, so I'm going to kind of cheat my work a little bit. So it's just the limit as x approaches 3 of x plus 3. And then finally, if we sub 3 into that, we get 6. So f prime of 3 is equal to 6. And that's all we needed to do with this. So there it is. All right, let's do it for this one. So f prime of 5 is equal to the limit as x approaches 5 of f of x minus f of 5 over x minus 5. And that is the limit as x approaches 5 of 2 over x minus, if I plug 5 into this, I get 2/5 over x minus 5. Remember, we have this nice little trick we can use to clear out complex fractions. Instead of doing the math up here and then flipping things around, I can just say multiply by 5x on the top and the bottom. This is legal math because you're just multiplying by 1. It's just a very special case of 1 that's going to make everything work out so much nicer, clear out all your fractions within fractions. So to do this, you distribute the 5x through to each term in this fraction. So 2 over x times 5x is 2 times 5, which is 10. 2 over 5 times 5x will just be 2 times x, so minus 2x. And down here, nothing cancels. You usually do not want to distribute anything through, so you just leave it factored like that. The reason you don't want to distribute anything is because often we can cancel something up here. So we can factor a 2 out of the top. Now see how this is backwards? If you just factor a 2 out, you get 5 minus x. And that's totally fine if you can remember that 5 minus x and x minus 5 cancel, but they cancel. Canceling means it divides to 1 normally, but in this case they divide to -1 because they're exact opposites. Or if you don't like that, if you see that it's going to be backwards, you can say, I'm going to factor out a -2 instead. That would change this to -5 plus x, or x minus 5. And then it's a bit more clear, and you don't forget about the negative sign, that those cancel, and you're left with this. Either way, you're left with -2 over 5 times 5 if you evaluate. And so that is our answer for f prime of 5. All right, this was pretty good practice using our limit definitions and kind of understanding how to use derivatives and how to think about them and compare. So please come into office hours if you have any questions for any of this.